So today we're talking about 6.3 and the separation of variables. We've touched on this a little bit, a couple of classes. We're going to start by looking at something you did in your homework a couple nights ago, which is the solution of a differential equation. So for example, we have e to the negative 2x, and we want to know, is that a solution of this differential equation, y prime plus 2y equals 0? What's the first thing we're going to do? Derivative. So I have y equals e to the negative 2x. I'm going to take the derivative y prime, and we'll get negative 2 e to the negative 2x via chain rule. I'm going to plug that in to this differential equation for y prime. And then I'm going to plug in my original y as well. They will cancel out. Thank you. So it is a solution. Okay. As we saw last time with the exponential growth or decay, we had this solution, CE to the KX or KT. And that's a general solution because we don't know what C is. We found last time that if we had that initial condition when time is 0, we could easily plug in a value for C. But our job today is not necessarily to find C, but kind of get everything separated so that we can find what a general solution may look like by using that separation of variables. So first thing, if you see a y prime, go ahead and rewrite it as dy dx. Okay, so I have dy dx equals 2x over y. How might I separate the variables so that y is on one side and x is on the other?
Multiply.
Basically, yeah, cross multiply. So I have y dy equals 2x dx. At this point, what can I do? Integral, good. What's the integral of y dy? Good. And the integral of 2x? X squared. And we're going to have our plus c on this side. Now, we're going to try to get y alone. I'm okay if it's a y squared alone, just as long as y is kind of by itself. There's no other constants or stuff like that. Okay. So how do I get, in this case, I'll just be getting y squared alone. How do I get it by itself?
Multiply everything by 2.
Multiply everything by 2. So I'm going to have 2x squared plus c. And that's my answer.
Why would you not? Why would it not be?
Because C is a constant.
C is a constant, so if I multiply it by 2, it's just another constant. Once it's, but it's still a constant.
The number of the constant like fluctuates.
It's just a, it does, I mean,
It's not going to have any effect on the X.
it's just a general solution. So C could be any value. We don't know what C is. And so as long as it's a constant, it will just stay a constant. Kind of like last time when we said e to the C is just a bigger constant and we moved it out front. It was still e raised to some value, but it's just another constant. So we leave it as C. Okay. Okay, let's look at the second one. It already is written with dy dx, so we don't have to change the y prime. I have to divide the y over and the x squared plus 4 over. So we'll have 1 over y dy equals x over x squared plus 4 dx. And then I should integrate, good. 1 over y dy is going to become ln y, good. This one is a little different, and we're going to have to use a u substitution to do it. Let's let u be x squared plus 4. What will that make du? 2x. Do I have a 2x sitting there? No, but I can put a 1/2 on the outside. So instead I have 1/2 the integral of 1 over u du. 1/2 of ln u. What is u? Good. And then we have plus c. I still want to get y by itself. How am I going to get rid of the ln on this side? E everything. Good. Okay. When a 1/2 or any number is outside of the ln, what are the properties of the natural log so that we can move that? It's an exponent. Good. So I can say this is the ln of the square root of x squared plus 4, because 1/2 as an exponent is a square root, plus c. The plus c is in the exponent. When I'm adding things in an exponent, what did we say we were doing to the base?
Oh, you were making it like the C goes to.
Right, the c is going to go in front because it's e to the c or times e to the c, which we said was a bigger constant. So we're going to have c e to the ln of square root x squared plus 4. What's going to happen with the e and the ln? They're- Yep. Yep. C times the square root of x squared plus 4. Okay.
It's basically, it's like the
Okay. So yes, this is similar to what we did last time, but we're not plugging in initial conditions or anything. Okay. Until now we have an initial condition and we want to find this particular solution. This is also set up a little differently. I have xy dx plus e to the negative x squared times the quantity y squared minus 1 dy equals 0. It is like it has already been kind of broken down for us, because when we're doing these ones, I have to get dy and dx on opposite sides, right? So they're not stacked. They're out like this. So yes, we can go ahead and subtract one to the other side. I'm going to subtract my smaller one. So I'll have e to the negative x squared times y squared minus 1 dy equals negative xy dx. I want x's on one side, y's on the other. So I'm going to divide this y over and divide this e to the negative x squared over. Okay, let's look at the y side first. Do we agree that this has a common denominator? Yes. Okay. So I'm going to write it as y squared over y minus 1 over y. What'll this first part become?
Y.
Y.
And then
Okay. I haven't taken the integral yet, but yes. Okay. On this side, what happens if there's a negative exponent in the denominator?
moves to the top.
It moves to the top. Okay. From here, what can I do?
Integral.
Yep. Integrate both sides. Integral of y
1/2 y squared.
and minus 1 over y.
ln y.
This one, we're gonna have to use u sub again. I know. We're gonna let u be x squared, which makes du 2x. Again, I don't have a 2, so I can put a 1/2 out in front. Actually, I'm going to move this negative out in front with it. Okay, what's the integral of e to the u?
E over U to the 2U. Wait.
It's
U
just e
minus-
to the u, right? E to the x is e to the x. Plus c.
And then on this side,
What do you mean by
Oh,
du?
I'm so silly.
What?
Where you say u equals x squared dx.
I'm sorry, this, yes, this should be du, not dx.
move that- move it
Okay.
like that right now.
That's like DX or DU?
This is du.
You like that?
Okay, so at this point, we're going to go ahead and plug in our initial condition so that we can solve for C instead of trying to move things around. So I'm going to have 1/2 times 1 minus the ln of 1 equals negative 1/2 times e to the 0 squared plus c. What's 1/2 times 1?
1/2.
Okay, what's ln of 1?
0.
0. E to the 0, 1 times a negative 1/2 would be negative 1/2. So I have this equation. What's going to happen when I add this negative 1/2 to the other side?
1.
C equals 1. So my particular solution that I'm looking for, my particular solution is 1/2 y squared minus ln y equals negative 1/2 e to the x squared plus 1. Okay,
The entire time you were just finding C.
yes. We did separation of variables, plugged in our initial value to find C so that we can get the particular solution of the differential equation.
You got the equation, is this what you would then plug in
Yes.
something else to find? Like if you got something else.
Maybe.
What X's? A good X.
Like if you did 2 X's, if you had to plug in.
Well, no, like it says
Oh,
like Y and then it probably says like 0, like if that was like 3, it was 21.
Yes,
Oh, I heard you wrong.
yes.
That's fine.
Okay, the last one. We want to find the equation of a curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. What does slope mean? Derivative. So dy dx is equal to y over x squared. Okay, if we cross multiply, we're going to get y dx equals x squared dy
Oh, and then you just flip it basically.
And then divide.
divide over, good. So I'm going to have 1 over y dy
Oh,
x to the negative 2 dx, okay, or 1 over x squared. Okay, so divide the terms over that you need.
oh, if you're right, just do negative.
What do I do next?
Integral.
What's the integral?
It's
ln y.
Line is my favorite word.
What about x to the negative 2?
That would be,
Negative 2.
no, it'd just be
X to the
negative
negative 4.
X, it'd just be negative X.
Negative
Or negative.
Negative x to the negative 1.
So
Okay, we can add absolute value on the y.
Wait, the lines on the natural log are absolute value lines?
Yes, babe.
That's not noticed.
Okay,
Can do parentheses. Yeah,
I'm just going to rewrite this to be a little simpler, so we don't have negative exponents. How do I get y by itself?
Why, oh, never mind. E it.
E it.
Just
Sure.
Guys, I should separate.
Oh, y equals.
What is what?
CE.
CE to the negative 1 over x. Good. So that's my differential equation.
Now plug 1, 3 in.
And we're going to plug 1, 3 in because that will give us our particular solution.
So then it's 3 equals CE to the negative 1 over 1.
Still
Good.
minus.
-1.
So then it's -1.
Each of the negative 1 is.
Hold on. Let's just write it as C over E since negative 1 is a negative exponent.
Oh.
So then what is C?
C is gonna be 3E.
3E. So my differential equation is 3E e to the negative 1 over x.
Oh,
Now, what is the power on this E?
negative 1.
It's 1. So if I have things with the same base,
You add them. so
I
it's
add the
zero.
exponent. So no,
So
it is
Oh,
3E
'cause- oh,
to the
it's
negative 1 over x.
Oops, I thought it was
plus
-1.
1. Okay. Homework is WebAssign. Homework is WebAssign.
Then we get taken.